Forgotten to record. Yeah, so today I'm going to cover on the biggest topic. I can call it the biggest topic in the world. So for those guys who are capable of doing refrigeration, you can try and do it, or HVAC. You can try and do it as a sub course. That will give you a lot of points because basically cooling takes 1/3 of whatever you're going to be asked in an interview or any design of a data center. The look at cooling was, remember we spoke of PUE, which is power usage efficiency. So the old data centers are losing right now because their air conditioning methods. Oh, nice stuff. You see, those are condensers that when I talk of them, he's just showing off this guy. Showing off his condensers here. Yeah. So all the companies that are going to, yeah, Brandon is just showing off here. So 90, I said 1/3 of your power goes to cooling, heating and cooling, no matter where you are in the world. So what method you use for cooling or heating is going to help your PUE. You see. So as we mentioned before, for a data center to be operational, right? Equipment for a data center like nowadays, it's no longer, the temperature used to be said must be below 25 degrees Celsius, right? But that's not the case anymore these days. Now, equipment which is being manufactured for data centers is able to operate at anything less than 40 degrees Celsius. So for that reason, they've realized that they don't really need to have their data center to run 24/7 at 18 degrees Celsius, which is most old data centers operate at 18 degrees Celsius. Sorry, I'm trying to mute this guy. Yeah. So most data centers before, I'm going to share you old information so that you understand better the new information. So most data centers used to operate at, on average, 18 to 20 degrees Celsius. And to try and keep the minimum, try and stay below this 25 degrees Celsius we talk about. So, but it's not the case anymore. Was more technologies coming in and can handle heat better. So we have data centers now, equipment that you must just operate under 40 degrees Celsius, you see. So 40 degrees Celsius, you can't even walk in a data center. It will be blazing hot, right? So what they do is, we said the intake needs to be 5 degrees lower the threshold. So if you are operating your data center, so you find most of the guys, they will try to say, okay, so let's try and stay at 30 degrees Celsius in our data center for all the equipment, so that our discharge will only add 5 degrees Celsius. That's what you will add, which is the discharge, the other side, when it comes out the other side. So to add 30, then it's 35. So it's lower than, so they'll measure this 40 degrees at the discharge. So as long as they are within, they set on their BMS, you're going to hear a lot about the BMS. They're going to set on their BMS to say the discharge temperature needs to be maybe 37 degrees, not more than 37 degrees. If in any way it reaches that 37 degrees, they get an alarm, you see? So that's the job of the BMS, monitors that stuff. That way, they are saving a lot on cooling. So that's why we are doing cooling today, because that's the biggest saving you can ever do on a PUE. So most data centers that are saying they can do PUE of 1.15 or 1.2 is because they you have researched very well in their cooling, on the subject of cooling, and that's the only way they are successful. So, and we're coming now to discuss cooling. So we're going to start with the evolution of cooling, right? What made all this possible, right? So we're going to start with what they call the refrigeration cycle. Is the reason why every single person has a fridge in their house, and it's the same principle that is being used also into the data centers. That was being used to data centers that made cooling possible even in rooms, in our rooms for air conditioning systems. It's exactly the same principle, right? That's why we need to discuss cooling, because it's, like I said, it's if you can save on cooling, you can have a better chance at running your data center, right? So we're going to discuss topic by topic, starting with where it all began, which is the refrigeration cycle. I know there are guys who have had this refrigeration cycle many, many times than once, but I'm going to state it as simple as possible so that everyone understands it. Like I said, for you to be a data center operations engineer or operations technician, you don't fix a fridge. No, you don't fix air conditioning. No, you just need to know where to touch. You just need to know what's the problem so that you can call someone to come and fix it. You see, so you don't fix anything. So yeah, I just had to put that one out there. You don't fix anything. Even a trip to breaker, sometimes you may have to write what they call the SOP. We're going to talk of those SOPs as well, standard operating procedures and stuff for data centers or anything. That will help you in your whatever career, wherever you go, because SOPs are very important. They make us all safe. Yeah. So refrigeration cycle. So that is, I can say, the root of every cooling thing that you're going to see in the world. It made refrigeration possible, right? And other people may call it the DX, right? And other people will call it what? I'm looking for the word, which is direct expansion, right? But it's one thing. So refrigeration cycle. I'm 100% sure that whoever is going to interview you for any data center question is going to ask you to explain that refrigeration cycle. So it's very, very, very easy, guys. It's very, very, very easy, right? It's you just have to know that there are four main components. You don't have to go detail like other guys that we're seeing here who are into data center, into refrigeration. They are very, very easy. So the first step, the first component is just the compressor, right? Which is nothing, just a motor, just to compressor, like the name it is, pressure for pumping, right? One. Then we have the condenser, right? Then we have the evaporator, right? Then we have the expansion valve, or some may call it expansion device, right? Where the name direct expansion came from, right? So these are the four things. I don't know if you can see. So it's the compressor, right? Then we have the condenser. Then we have the evaporator. Then we have the expansion valve, or just expansion device. Fancy word, but it's nothing, just a spray. You guys spray the deodorants, right? So same principle with the expansion valve. That's how it works, right? Yeah, so I'm going to explain to you in detail. So for the compressor, you just have to state what happens with the compressor, right? Just gives more pressure, right, to our refrigerant. And what else? That means as long as you have more pressure, that means you have heat, right? So temperature is increased in the refrigerant. The condenser, like the name says, that's where condensation happens, right? Condensation, I talked about back in school. Condensation, that's when a gas is turning into into a liquid, right? That's exactly what it does. Then the evaporator, it's exactly as it says. That's where evaporation takes place, right? That's a process where we're turning now a liquid back to gas. Then the expansion valve, there is some releasing of pressure, right? We're releasing pressure, like I said, just like a air conditioner or your spray that you use, deodorant. It's all compressed inside. So you press it, then it releases. So I'm going to explain every point. I'm sure you guys have researched all this and it looks so simple, but these are the points that they look at. They don't expect you to just claim it, but you need to understand it. Where someone can just ask you any point, from any point, what happens here? So you need to be able to explain it. So I take it, for example, it goes like this. It started there. Let me take a paper. I really need to develop my computer skills so I can show you guys drawing on them, but unfortunately I can't. So it always starts at the compressor, right? That's where we put in our vapor gas, the refrigerant, they call it refrigerant, right? The guys who are doing refrigeration. So it always starts at the compressor. That's where they put in the gas, right? So what will happen is the compressor will give it, what you said, you compress it, give it more pressure. That is, we have now more pressure and more temperature, right? That's where the biggest change happens. More temperature and more pressure. Then it goes to the condenser. See. So I'm just going to write it as a coil like this, because it is a coil. A condenser is just a coil, right? Then from there, it goes to the expansion valve, right? Then it goes again to the evaporator E, right? Which is again a coil. Again a coil. Back again to the compressor. Gets the pressure. So I'm going to explain now the states, was that the changes in this thing, right? But this is exactly what it does. From compressor to condenser, from condenser then through the expansion valve, then back to the evaporator, then back to the compressor. It's a cycle. That's why it's called a refrigeration cycle. But I'm going to explain now the changes. That's all they're interested in. This, you know it like the back of your hand, but you need to be able to know the explanation behind it. So, right? At first, we put in a gas, right? Which is refrigerant at the compressor. We give it more pressure and more temperature, right? Then it goes to the condenser. It's still, here it changes state, right? From a gas to a liquid, but still with high pressure. But here it also discharges some of the heat, because remember, whenever we experience a change, right, it's going to change state and it's going to release some of the heat, but it still has its pressure, right? That's what you need to understand. Here it changes, so it releases some of the heat. They say from 5 to 12 degrees. That's what it drops here. I'm going to explain in detail the condenser later, but this is where it changes from, right? From a gas to a liquid, but it still has its pressure, but now it's a cool liquid, right? Cool, high pressure liquid. Then it goes here to the expansion valve. Like I said, with the exactly like a deodorant, it's full in there. When you press it, this is where everything was made possible. That's where the name expansion comes from. The direct expansion comes from. This will regulate how much gas it releases through here. How much liquid? It's a liquid, right? So it will release the liquid, right? Little bit by little bit, but it will be governed by one thing, which is part of the one thing which is part of the expansion valve, which is called the, let's call it a bulb. So this bulb it's normally sitting on the other side. So it comes from there, then it goes to the other side, right, of the evaporator, not the entrance, but the exit of the evaporator, right? So, but for now, don't worry about it. So it's just like a diaphragm, So it opens and closes, letting out that liquid according to whatever temperature setting you're going to set for your evaporator, right? If you want the room to be cold, if you want your room to be very cold, it will more gas. If you want your room to be less cold, it will reduce the gas, right? So that's exactly what happens here. So that is made possible by when the gas now goes through, it's when the liquid now goes through, it's still a liquid. So it changes, it's still a liquid into the evaporator, it's still a liquid in the beginning of the evaporator, then it will change into a gas. Why? Because of the heat that this evaporator, because you're taking heat from the room. So I need to explain this. So the condenser is always outside. The evaporator is always inside your house, right? And I just wanted to show you guys what an evaporator looks like. Unfortunately, I can't show my screen, but I'm sure you guys have seen a few evaporators on the. So I'm going to send it in the group, the evaporator now, how it looks like. So those who can access the group can. Just a standard evaporator. So those who can.
Yeah.
Okay, so sorry, now I can't find the picture yet, but I'll show you. But you'll see it, it's mounted down right at the back of my head. That's the evaporator. Sorry, that's the evaporator right behind me. So what happens is I get my remote, right? I reduce temperature here. I reduce temperature here. The evaporator is going to, that's where the setting happens, right? The evaporator is going to set the temperature, then whatever that this discharges, right, it's going to send to say, okay, Now we demand more refrigerant. So this will send signal back to the expansion valve to say, guys, open up more, diaphragm, open up more. Then it open up more, the more refrigerant now will flow. That means more refrigerant flowing in there, which is a liquid. The fan will increase the speed and taking all the coldness. Because when the expansion valve releases, right, this would drop temperature dramatically. That's where the temperature drop happens here. It will drop temperature dramatically. And all the temperature, all the heat. Guys, can you please mute your just now today? I'm trying to mute. Guys, just try and mute your PCs. Okay, sorry for that. So it's going to release here. That's where when it was here, it's high pressure on the other side, which is the condenser side. When coming from the condenser, it's high pressure liquid. Then here the expansion valve is going to release, right? And according to whatever demand you need, right? And it's going to drop temperature dramatically, right? I'm not sure of the numbers now, but it drops the temperature. Then here it comes in as a liquid, low pressure liquid. So this is high pressure liquid. I just want you to note high temperature gas from the compressor. Then it goes to the condenser. That's when it turns into a liquid, but high pressure liquid. Now it's less temperature. It's a warm liquid. It's not really cold. It's still warm liquid, but it loses some of the temperature here, some of the heat here in the condenser. Then it comes here. It's still a high pressure, warm liquid. Then at the expansion valve, that's where it gets turned. You release it on the other side of the expansion valve, because you are not releasing, you are not putting all of it, you are putting only a few. Then it becomes less pressure, cold liquid, right? Then it goes to the evaporator. In the evaporator, that's when it dumps all the coldness. Then it goes back again, back to the compressor where the evaporation takes place here. It goes back again as a gas, or just call it as a vapor. Back to the compressor, given the high pressure again, because here it's at the exit of the evaporator, it's a low pressure liquid. No, so low pressure gas. Now it's a gas. It turns towards the evaporator. That's where it evaporates back to the original. So the compressor only pumps what? The gas, vapor only, gas, not liquid. There's no liquid at the compressor. So those are the steps that I just want you to know. So please just don't worry about a lot of things. Just worry about where it changes its state. That's all they're asking for. I know there's guys who may explain it better than me, but I'm just pointing out the points where you are going to be asked. This is all you really need to know, right? I mean, then for a condenser, you need to know that this is just a normal. It's normally fan-cooled condenser, which is, I'm sure there's Brandon. You see, Brandon's here, has condensers here. These are condensers. That's where they dump the air, the heat outside. So it's taking the heat from the building, right? From inside the house, a room, like me here, this one behind me. And the refrigerant is the one that takes it off, was when it evaporates, that when it takes all the heat the compressor. The compressor presses it, gives it more pressure, more heat, so that it can dump some of the heat here at the condenser, which is where Brenton actually is sitting. That's at condensers, and it these are fan cooled. You see these big fans, they are blowing across here, across this coil, and it discharges some of the heat. Then it goes back again to the expansion valve. Now condensation happens here, is a liquid, low pressure, is a high pressure liquid to the expansion valve. That's when it changes state now into a low pressure liquid. Then goes back to the evaporator. See, process goes on and on and on. So you just need to be able to explain only those points. I know it sounds a lot, but for you guys, you already started. I'm sure some of you are making noise for you because you already know this stuff, but that's exactly what you need to know. This is all odd stuff, but this is where every concept is based on. So you only need to know that in terms of condenser maintenance, most of them, these are actually almost all of them, they are air cooled, and they have fins which are made from aluminum, from a high conduct, because there's conduction that happens, because the coil, it's literally a coil, so that it increases what? Surface area. Those are some of the questions you may be asked. That is if someone realizes that you know more, they may go down to those questions to try and gauge your knowledge. Because remember, when you're going into an interview, especially for these ones, they are interviewing you at the same time rating what level are you, right? So you may start from level 1, which is the first entry level, level 2, level 3, level 4. So the person that's going to interview you will determine how much do you know of everything. So those questions may be asked to say, why do they have those fins in there? So the fins is just to improve on increasing surface area, because it's touching the coil, which is literally a coil to increase surface area, and the fan is going to take, so there's conduction, which is where the fins are right in contact with the coil, right? Then there's a fan that is blowing. So when it's in contact, that's conduction. Then when the fan, because it's same medium, so it's a metal to a metal, so that's conduction, right? And if a fan blows through, that's now convection, because the fan is blowing through to take the heat away from the fins, right? That's convection. So you may be asked those things. Same thing with the evaporator. So I'm not going to go down into detail, but now with this inverter, like this one is standing next to, no, I don't think it's this one, but in all cooler areas, they'll make it an inverter one, which is the reverse can be true. You turn it around. Now the inverter, your house, you want your house to be cold, you want your house to be hot, warm, and out. And all you need to do is you put temperature up, then the reverse happens. Remember, here was hot, and the condenser was hot, but it will be reversed. But I don't want to confuse you with that for now. Just know that, because I know this is the basis of every single thing. I don't know if guys you can understand me, but I'm sure you guys have researched. So I recommend one channel you can visit. It's called Engineering Mindset. Please visit Engineering Mindset and just check on this. They may show you the simplest forms, and they may explain this way better than me. Just remember the points I've just mentioned to you, because they may not mention some of these things on there, because those are the important things. Most of the things are not really necessary. And so we go on the next step, which is the question which is asked a lot, which are called chillers. So chillers, they are just what you explained right now. So most of the chillers Those are the ones that are used for bigger systems or bigger buildings, right? Was this just for a small room? You can't really cool down something using this on a big data center because you're talking of a big system. So a chiller, it can be two types of chillers. There is a water-cooled chiller and a fan-cooled chiller, which is the air-cooled one, right? You just need to be able to explain those things, right? The difference between those two. So the chiller, remember, from the refrigeration, that's why I started with this refrigeration cycle, because a chiller, we have exactly the same two things. We have the compressor, same components, right? But on the chiller, they concentrate mainly on the condenser and the evaporator, right? And it's very important to know that we're going to start with the water-cooled chiller, right? So for the water-cooled chiller, I have to mention it to you guys that they call it water-cooled chiller because why? The reason why it's called a water-cooled chiller is because what medium they use to cool down the condenser, that's all it is. Right? They all have water. Just some of them have what medium are they using to cool down or to dump air outside the building, right? What do you see on the outside? So some of the chillers, you may see a cooling tower, right? That means it's a water-cooled chiller. If you see fans on top of the building running, that means it's a fan-cooled chiller. That's all. And for the water-cooled chiller, right, there are things that you need to know. There is 3 circuits of liquids, right? Remember, guys, most of you guys are all electrical, but there's 3 circuits of liquid that you need to know. Those liquids never meet. So there's water that rotates first in the evaporator. The evaporator, remember, it's always inside the building. Always inside the building. But here now for the chillers, it's not the evaporator, it's not the air that comes in, right? It's the water, because remember it's a chiller, so it releases chilled water. That's I'm pointing out only the main points that you need to point out. The chiller uses water, always uses water on the evaporator, but from chiller, that means it produces chilled water, right? Cold water. Temperatures vary from 9 to 13 degrees, temperature of water that leaves the chiller, right, into the building, right? And it will have the same principle of a coil, right? And we have a fan that runs across, that blows air across the cold coil, releasing all the pressure. Like same thing like you blow air or kafuriza moto. If someone stands on the other side, you can feel the heat more. That's exactly the principle. That's how they made the chiller. So chillers, they use water, right? In running in the building, which is chilled. So it has an entry. It goes in, it's cold, it comes back a bit warm, back in the chiller. So you need to remember that circuit, the water in a chiller, in the evaporator, will never mix with the water. There's a circuit number 2, which is circuit for condensed water if it's a water-cooled chiller, right? So that water will run into the condenser, which is sometimes, most of the times, it's inside. The condenser is inside. So the condenser will take water, right? But you guys just go and watch videos, because videos will explain this better. I just want to point at the main points that are going to be asked around this stuff. So water from the chiller, from the condenser, runs, that's circuit number 2, from dumping, taking it from what? Circuit number 3. Circuit number 3, which is they always have direct expansion. So the link between these two things, which is the condenser and the evaporator, how they pass each other, it's just like a relay, right? You pass the next, you pass the next, but this is just continuous relay. So the evaporator takes air from the cold, hot air from the building, dumps it to the direct expansion, which is the one that we talked, the refrigeration cycle. It's there. Then it takes air, it dumps it, it takes the heat, dumps it to the condenser. The condenser takes it outside the building, which can be cooled by a fan or a cooling tower, right? Those are the main points that you're going to be asked. How many seconds do you have of liquids? You just say, I have 3 seconds. And what of a refrigeration cycle, which is the refrigerant, which is the middle one, which transfers heat or between the condenser and the evaporator. That's all you need to know, right? And you can go deeper by reading through it, because I know this is why I told you guys you need to read before me, because I know this stuff is a bit difficult. So pointing out the things that are normally asked, right? Water cooled chiller or air cooled chiller, right? Those are two. And what defines it is because whatever medium you use to cool down the condenser, that's what defines the name of the chiller, right? So I hope you guys understanding it. And so we go to the next step. So chillers, I'm not gonna give you chillers how they look like. You're going to check on your stuff. I told you the link. You need to go and check on what do you call it? Engineering mindset is one of the, yeah, I think this is one of the easiest sites that they explain and show diagrams of this stuff. So I need to, after this thing expires, I'm going to come back and do air handling units, right? Because those are the most important ones. So with the time that I have right now, I'm going to main talk of, wait a little bit. Wait a little bit. No, it's all right. I'm going to wait for this to restart, and we come back and start on the air handling units. So thanks. So. Okay, now it's taking time. Yeah.